I need to find Norton equivalent at terminal A and B for the left part of the circuit as shown by the arrow, and then using that Norton circuit I want to find the current I or I1, let's say I, that is going through 5 ohms this 5 ohms resistance. So in order to find Norton's equivalent circuit, what I will do, first I will replace this part by a short circuit. So terminal A and B, at that point, at that terminal I will remove the circuit, the right this part of the circuit, and I will replace it with a short circuit. So this is A here and this is B here, and this is the short circuit, and the short circuit current will be the Norton current. So this is short circuit current, which will be the Norton current. So 6 ohms there, 12 volts there, 4 ohms and 2 amps. So in order to find this current, what seems convenient is converting this part, this current source and the parallel resistance, into a voltage source and a series resistance. That way we will end up having just one series circuit. So the voltage source will have polarity in that direction. There is this 4 ohms resistance, and there was already a 6 ohms resistance, and there is this 12 volt voltage source, and this is the short circuit current which is going in this direction. So the value of the voltage source, the converted after the source conversion, will be 2 times 4, 8 volts. So that will be the value there. So we have two voltage sources in a series circuit. They are opposing each other in the direction. So this is higher, this is lower, so the value of the resultant voltage is of course in this direction. So current ISC will be negative. I'm just writing directly from observation. So 12 minus 8 will be 0.4, and the total value of the resistance is 12 minus 8 is 4, sorry. So that's 4 there, 4, and the sum of 4 and 6 is 10. So that's the value of the current ISC, which is basically minus 0.4 amps. So this is the Norton current, which is the short circuit current. Now I need to find the Norton's resistance. So this is the current, and it will go since the current is actually going in this direction, in Norton circuit the direction of the current source will be like that. So that's there, and then I need to find Norton's resistance, which can be found by just making the sources inactive. So if I go back to this circuit and if I make the sources inactive, that is the current source open here and this voltage source short circuited, that will leave me to something like this. The current source here is gone, so that's not there anymore. This is 4 ohms and that's 6 ohms, and here is the voltage source which will be short circuited. So the resistance seen in this direction is 6 ohms and 4 ohms, so the total resistance is 10 ohms. Just they are in series, 6 and 4, so that's 10 ohms. That's the Norton resistance. So this is terminal A and this is terminal B, and now I will reconnect the right parts of the circuit. So this one is 5 ohms and a current source, so 5 ohms resistance, and this is the current we are interested in, so that's just I, and here is a current source that's going upwards of 4 amps, so that's the value. So now I have two current sources and two parallel branches. This one is 5 ohms, the value of the resistance. So in order to find current I, what I will do, I will use principle of superposition since there are two sources. So first I will consider this source, making the other source inactive. So this branch will be open. This branch we can just ignore this part for the first case, and then in order to find the contribution of this one, I will ignore this current source. So when I consider 0.4 amps current source first, I have I, and I have just these two branches and one current source, and I can apply current divider rule, and the current will of course be in the other direction, so that will be a negative 0.4 divided by sum of the resistances multiplied by the resistance of the other branch, which is 10. So that will give me 0.4 minus here, and this is 15, this is 10, so basically minus 0.4 times 2 over 3, so that's minus 0.8 over 3 amps. So let's leave it like that. This is the contribution of one part, let's call it IA, which is the contribution of the one of 0.4 amp source source. And this one is, now I need to consider this source, which is 4 amps. So when I consider that, let's consider this one, I will have this time the current I will be positive because this is going in this direction, and of course I will come down, so that's there. So 4 here, and again there are two parallel branches, 10 and 5, so that's 15, and multiplied by the other branch, same actually, just as same as before, only the value of the current source is changing. So that's 2 over 3, so that's 8 over 3, so I'm calling it IB. So my total I will be IA plus IB. This is the contribution of 0.4 amps current source, and this is the contribution of 4 ampere current source. So using principle of superposition, I am just adding them. So this one is negative according to the direction assumed, 0.8, sorry, and this one is, sorry, that's 8 over 3. So, and this is becoming minus, sorry, plus 3, and that's 7.2 amps. So when I divide by 3, it becomes 2.4 amps. So that's the value of current I found by using Norton's equivalent circuit.